Trees are everywhere in computer science. File systems, databases, compilers, HTML. Once you understand binary trees, every algorithm that follows becomes clear. Let's start from zero. A binary tree is a hierarchical data structure. It's made up of nodes connected by edges. The rule: each node can have at most two children, a left child and a right child. The very top node is called the root. Every tree has exactly one root. It's where every traversal starts. When a node connects to a node below it, that relationship is called parent and child. Node 1 is the parent. Node 2 is its left child. Node 3 its right child. Two nodes that share the same parent are called siblings. Node 2 and Node 3 both have Node 1 as their parent, so they are siblings of each other. Left and right are not just labels, they define the structure. A node on the left side and the same node on the right creates a completely different tree. Every node is the root of its own S-soup tree, the node itself plus all its descendants. Node 2, together with 4 and 5, forms its own subtree. Nodes with no children are called leaves. They are at the bottom of the tree, the endpoints. In this tree, 4, 5, 6, and 7 are all leaves. Nodes that have at least one child are called internal nodes. Here, 2 and 3 are internal. They have children below them. The degree of a node is how many children it has. Node 1 has 2 children, degree 2. Nodes 2 and 3 are also degree 2. Leaves have no children, degree 0. Nodes at the same distance from the root belong to the same level. The root is level 0. 2 and 3 are level 1. 4, 5, 6 and 7 are level 2. Height is the longest root to leaf path counted in edges. Watch the highlighted path, root 1 down to node 2 down to leaf 4. 2 edges. Height equals 2. Depth works the other way. It's the number of edges from the root down to a specific node. Root has depth 0. Nodes 2 and 3 are depth 1. The 4 leaves at the bottom are all depth 2. A path is a sequence of connected nodes with no repetition. Here, 1 to 3 to 7 is a path of length. So path length is 2. In code, a tree node is just a class with 3 fields. That's all you need to represent any binary tree. Was stores the node's value. It can be an integer, a string, any data type. Left and right are references to the left and right child nodes. If a child doesn't exist, they're null. The constructor takes a value, sets left and right to null. Every node starts as a leaf. You connect it by setting the parent's left or right pointer. One class, 3 fields. From this, you can build binary search trees, heaps, tries, every tree structure we covered. Subscribe to see them all.